Hello students, hope you all know about the covalent bond and ionic bond. The process of formation of covalent bond and ionic bond. Covalent bonds are formed by the sharing of electron, while ionic bond are formed by the complete transfer of electron. Both have the different ways of the formation of bonds. But if you give the example of a molecule having covalent bond, I can say, dear student, it may have some ionic character. If you give a molecule or the example of the molecule which is forming ionic bond, I can say, my dear student, it has an ionic character, but some covalent character is also there. So, as a conclusion, what we can say? We can say that no bond can be perfectly covalent and perfectly ionic. It means we can say covalent bond have some ionic character while ionic bond have some covalent character. Okay, it may be correct or not. But how can we prove that a covalent bond have ionic character while ionic bond have a covalent character? Let's see the diagram. This is the example of ionic bond because ionic bond are formed between metals and non-metals. Li is a metal, lithium, while Cl is a non-metal. There is an electrostatic force of attraction between lithium cation and chlorine anion. When these cation and anion come close to each other, you all know, my dear student, that the cation is very small in size is in comparison to the anion. When they come close to each other, you can observe that anion is getting polarized, getting attracted toward the cation. That is, the electron cloud of anion is getting distorted. It means some of the electrons getting shared toward the cation. It means in this ionic bond, the red color is showing some sharing of electron cloud. So some covalent character is developing. Am I right now? Yes. Cation, more positive charge the cation have, it can polarize the electron cloud of anion more. Okay. So we can say more the polarizing power, the word polarizing power will be used for cation. More the polarizing power of cation, more will be the covalent character. Okay. If more charge, small size, then the polarizing power of the cation will be more. Similarly, as anion is getting polarized, its electron cloud is getting distorted. So what we can say, the polarizability, that is tendency or ability to polarize. I say always polarizability means ability to polarize. It means anion is getting polarized. Larger the size of an ion, more easily it get polarized because its electron cloud is far away from the nucleus. So, larger the size of an ion, smaller the size of cation will lead to the more covalent character in ionic bond. I think it is clear to you. But I'm not going in detail about all the trends to calculate the covalent character in ionic compound or ionic character in a covalent compound. I want to tell you the short trick. How can you identify the covalent character? Covalent character, I am representing it as Cc, is directly proportional to the polarizing power of the cation. More the polarizing power of the cation, more will be the covalent character. This polarizing power of cation is related to the charge of the cation. It means more the charge on the cation, more will be the polarizing power. It means if a cation having +2 charge, if a cation having +3 charge, then the cation having +3 charge will have a more covalent character. Covalent character directly proportional to the charge on cation, but my dear student, it is inversely proportional to the size of the cation. If the size increases, then the charge density will decrease. Similarly, we can say Cc means covalent character. Covalent character directly proportional to the polarizability of an ion. That is ability to polarize. It means larger the size of an ion, it can easily get polarized. So we can say covalent character is directly proportional to the charge on anion as well as the size of anion, but it is inversely proportional to the size of cation. You can take the screenshot of this. It is very important to calculate the to identify the Fajan rule, or to identify the what we can say the covalent character in ionic bond. But one thing, my dear student, before going to the examples, there is some exceptional case. Cation with 18 electron in valence shell, you know, if there are 8 electron in the valence shell, what we say? Octet is complete, or the noble gas configuration. But if there are 18 electron in the valence shell, you are thinking, sir, it's not generally possible, that is having 18 electron in the valence shell. So I'm using the word pseudo noble gas configuration, not real or the fake noble gas configuration. It is possible only for the d block element, that is, you can say the transition element. Cation with 18 electron in the valence shell, that is pseudo noble gas configuration like Cu plus, Ag plus, Au plus, Zn2 plus and Cd2 plus, are always more polarizing than normal cation having just 8 electron in the valence shell, that is having complete octet, normal complete octet. But you are thinking why? I can explain one thing. You know the lanthanoid contraction, that d block element have a poor shielding effect. As a result, the effective nuclear charge for the d block element is high, resulting more polarization than the normal cation. You can see, my dear student, on the screen that NaCl and CuCl both look like same. Na also have a +1 charge, while Cu also have a +1 charge here. Almost both have the same charge and nearly same size as well. But due to the poor shielding effect of the d orbital involved in Cu, its effective nuclear charge increases, it's polarized more than Na+. So the covalent character of CuCl will definitely be more than NaCl. Remember this type of question are asked in NEET and JEE examination. MgCl2 and ZnCl2. It is Mg is as block element, while zinc is a d block element. Both have Mg have +2 charge, while Zn2 plus, you also know that it have the +2 charge. But you can see that Zn2 plus have the d orbital having a poor shielding effect. That's why its effective nuclear charge is much more. So ZnCl2 is more polarizing or more covalent than MgCl2. Now moving to the examples. As you can see here, LiCl, NaCl, KCl, RbCl and CSCl. You have to comment what is the correct order of the covalent character. LiCl, NaCl, KCl, RbCl and CSCl. You have to identify which things is common, either cation or anion. As you can see, in this case, anion is common. Anion is common. Ignore it. The thing that is common you have to ignore. Which is different? Cation. It has plus charge. All the cation have +1 charge. So we cannot distinguish their covalent character by the charge. Then how can we distinguish their covalent character? We can distinguish the covalent character by their size. As you can see, all the cations belong to the group 1, or you can say the alkali metals. Down the group size increases, so CS is bigger in size while Li is smaller in size, and you know covalent character is inversely proportional to the size of the cation. So the most covalent will be LiCl while least covalent will be CSCl. So the correct order of the covalent character in this ionic bond is this. Can you predict the correct order in the second example? Yes. all the examples belong to the group 2. In this case, anion is common also, just like in the first case. Okay. Now Cl is common. Be2 plus Mg2 plus Ca2 plus Cr2 plus Ba2 plus all have the equal positive charge, but the size. B is smallest in size, more charge density, more positive charge density, more polarizing power. So the covalent character will be like this. These covalent characters are in non-aqueous solution, remember. But coming to the third example, little different. PbF2, PbCl2, PbBr2, PbI2. Here, in this case, cation is same. Cation is same. The cation have plus 2 charge, plus 2 charge, plus 2 charge, plus 2 charge. And also the cation is same. We cannot identify the covalent character by the species either cation or anion, which is common. So we have to focus on anion. F2, Cl2, Br2 and I2. These are anion, remember. Larger the size of anion, because in this case anion also have the same charge because they belong to the same groups, group 17 or halogen family. So we can identify or distinguish them on the basis of the size. See, iodine, bromine, chlorine and iodine, fluorine. Down the group size increases, so I2 have the maximum size. So this anion has the more polarizability. So the covalent character will be like this. Hope you enjoy this video. Last example for these two examples is for you. You have to solve these two examples and write the correct order which is possible according to you in the comment section. Hope you enjoy this video. We'll meet you in another video. If you want such type of interesting video, please comment and subscribe my channel. Also, you can tell which next video you want, on which topic you want. If you have any doubt before the exam, I can make the short video with tricks so that you can achieve the good marks as well as the success in your exam. All the best. Thank you so much for watching this video.